becomes ln x plus 2 minus ln x is equal to 2. So bring the ln terms on one side, the negative becomes division is equal to 2. Converting the logarithmic form into exponential form, it becomes e squared. So x plus 2 is equal to e square x, getting all x terms on one side. So e square x minus x is equal to 2. So x common, e square minus 1 is equal to 2. So x is equal to 2 upon e square minus 1. Use the calculator to get the answer in three significant figures, which is 0.313. Now coming to the second question, expansion. So it is 1 plus x and square root is whole to the power of 1 upon 2. So expand that, 1 plus x. It becomes 1 plus nx. Then n minus 1 upon 2 factorial x square and so on. So it becomes 1 plus x, 1 minus x. Then if at all I simplify this one, it becomes minus x square upon 2 and so on. Now I expand it further. So 1 is multiplied with 1 plus x, so it becomes 1 plus x. Negative x is multiplied with 1 plus x, so it has become negative x and negative x square. Then finally negative x square upon 2 is multiplied, so it becomes negative x square upon 2 and negative x cube upon 2. But I want only the term still x square, so negative x gets cancels 1 and these two becomes negative 3 upon 2 x square. This is going to be the answer. Question number 3. Show that this has only one stationary point between this interval. So stationary point, whenever it says find dy by dx, so dy by dx is equal to cos square x, cos x or cosine x, e power x derivative is e power x minus e power x as it is, cosine x derivative is negative sin x. Find dy by dx and equate to 0, so it becomes e power x cosine x plus sin x upon cos square x. Do the cross multiplication, so I get e power x times cosine x plus sin x is equal to 0. We know that e power x can never be 0, so I am left over only with cosine x plus sin x is equal to 0. So sin x is equal to negative cosine x divided by cosine x on both sides, so it becomes sin x upon cosine x is equal to negative 1, tan x is equal to negative 1. So x is equal to tan inverse negative 1, which gives me the value pi upon 4, negative pi upon 4, only one value between that interval. So it has only one stationary point. That's question number 3. Coming to question number 4, the parametric equation, show that dy by dx is cosine cot theta. So first find dx upon d theta, which is a times 2 theta derivative 2, sine 2 theta derivative is cosine 2 theta times 2 chain rule. Similarly, dy by d theta, a 1 derivative 0 minus cosine derivative is minus sine, so it becomes positive sine 2 theta. 2 theta derivative is 2. Now I want dy by dx. Dy by dx is nothing but what? Dy by d theta upon dx upon d theta. So dy by d theta is 2a sine 2 theta. Dx upon d theta is take 2 common, 2a times 1 minus cosine 2 theta. So we can see that 2a gets cancelled. Sine 2 theta is 2 sine theta cos theta. 1 minus cosine 2 theta is 2 sine square theta. Then what else can be done is further 2 and 2 cancels. 1 sine theta cancels. I'm left over with cosine theta upon sine theta, which is cot theta. Question number 5. The polynomial 4x cubed minus 4x squared plus 3x plus a is denoted by p of x. So p of x is equal to 4x cubed minus 4x squared plus 3x plus a. It is given that 2x squared minus 3x plus 3 is divisible by that one. So I am going to find it on the long division. So we shall try for the long division. So I take this p of x and do the long division. So let me bring this p of x over here and do the long division with 2x squared minus 3x plus 3. So I take the first term inside, first term outside. So 2x squared, it should be multiplied with what to get 4x cubed. So it's obviously 2x. So multiply with 2x I'm writing over here 2x. So multiply each term with 2x, it becomes 4x cubed minus 6x squared plus 6x. Draw a line, change the symbols, it becomes 2x squared minus 3x plus a. Now again take the first term inside, first term outside. 2x squared should be multiplied with what to get 2x squared? So obviously it is plus 1. So multiply with plus 1. So it becomes 2x squared minus 3x plus 3. Draw a line, change the symbols, a minus 3. Because we know that it is divisible, so the remainder should be equal to 0. So a minus 3 is equal to 0. So means a is equal to 3. That is the answer for the first part. When a has this value, solve the inequality p of x is less than 0. So our p of x was 4x cubed minus 4x squared plus 3x plus a value is 3. So now we have done the long division and we saw that it is divisible with 2x squared minus 3x plus 3, and we got a linear factor as 2x plus 1. So it can be factorized like this. It is being asked to prove that this is less than 0. So we have a quadratic term and a linear term. So first we take a quadratic term, 2x squared minus 3x plus 3. We'll try to check it out whether it is having less than 0 or not. So for that, I'm going to do a completing square. So I got like this, 2 common, x squared minus 3x upon 2 plus 3. So I do the completing square, it becomes x minus 3 upon 4 whole square minus 9 upon 16 plus 3. So this becomes 2 times x minus 3 upon 4 whole square minus 9 upon 8 plus 3. So this becomes 2 upon x minus 3 upon 4 whole square. Then some 24 minus 9 is 15. 15 upon 8. We see that square term is always positive and 15 upon 8 is also positive. So this is always greater than 0. So this term can be, what it says is never, what it says, negative. Never negative. So I'm left over only with 2x plus 1. So 2x plus 1 should be less than 0. If 2x plus 1 should be less than 0 means x is less than negative 1 upon 2. That's going to be the answer. Question number 6. Express 5 sin x plus 12 cos x in the form of r sin x plus alpha. 5 sin x plus 12 cos x. So a is equal to 5, b is equal to 12, so r is equal to square root of a square plus b square, which is 5 square plus 12 square, which is nothing but what, 13. So what am I going to do? Multiply and divide by 13. Now in the question it is being asked sin x plus alpha. What is sin x plus alpha's expansion? So it becomes sin x cos alpha plus cos x sin alpha. So we see that with sin x cos alpha is associated. So this is going to be r. We got it out. So 13 and 5 upon 13 is going to be cos alpha. Whereas 12 upon 13 is going to be sin alpha. So according to the requirement, we have assumed that 5 upon 13 is cos alpha and 12 upon 13 is sin alpha. So what is that? Sin alpha we have assumed as 12 upon 13. So alpha will be sin inverse 12 upon 13. So we take the calculator because it is in degrees mode. Keep the mode of the calculator in degrees and quickly do sin inverse 12 upon 13. So it should be giving you something around in one decimal place 67, or two decimal places 67.38. 67.38 degrees. So it becomes 13 sin x cos 67.38 plus cos x sin 67.38. So it becomes 13 sin x plus 67.38. That's going to be the answer. Coming to the second part, hence solve the equation this is equal to 11 and all the solutions between 0 to 180. So we go to the next page. 5 sin 2 theta plus 12 cos 2 theta is equal to 11. 5 sin 2 theta plus 12 cos 2 theta is equal to 11. Just now we have done that one. Is this is 13 sine x. Instead of x, it is 2 theta plus 67.38 is equal to 11. So sine 2 theta plus 67.38 is equal to 11 upon 13. So 2 theta plus 67.38 is equal to 11 upon 13. But it should be sine inverse 11 upon 13. Sine, I bring this side, so it becomes sine inverse 11 upon 13. So quickly take the calculator and do sine inverse 11 upon 13. So it should be giving you 57.79. But it's between 0 to 182 quadrants values. So 2 theta plus 67.38 is equal to 57.80, or another one value, we are going to take it as 2 theta plus 67.38 is equal to 122.20. So these are the two values that I'm going to take it out. But if I take like that, what will happen is I may not be able to get the correct answer. So therefore, what am I going to do? I am going to do by the, what is this? The general solution method. General solution method is very simple. So what am I going to do? It is, first of all, I am going to take what is the sine inverse 11 upon 13. 11 upon 13, which is 57.80. So 2 theta plus 67.38 is equal to n pi plus minus 1 whole power n times 57.80. So whenever sign it is there, n pi plus minus 1 whole power n times this answer. So this is a general solution. Now make the theta as a subject. So this is very simple. If we just remember this formula, n pi plus minus 1 whole power n, 57.80 minus 67.38 divided by 2. Now substitute n is equal to, we can take n is equal to 0. If I take n is equal to 0, it becomes a negative answer. It becomes 0 times 180, 0 times 180, then plus 57.80 minus 67.38 divided by 2, which gives me negative 4.79, which is relegated or which is not considered. So if I take n is equal to 1, so it becomes 1 times 180 and minus 57.80 minus 67.38 divided by 2. 1 times 180 minus 57.80 minus 67.38 divided upon 2. It should be giving me 27.41. So 2 decimal places. That's going to be the correct answer. Now I try n is equal to 2. So just change n is equal to 2. So it will become 2 times 180, which is 360, minus 1 whole square become positive, plus 57.80 minus 67.38 divided by 2. So it becomes positive. Take the calculator, quickly key in these values, and you should be getting it out 175.21 degrees. That's going to be the final answer. So but now in the answer he has never told that it is 2 decimal places, just only give all the solutions. So therefore our answer should be in 3 significant figures, so it should be 27.4, and if at all it is this one in 1 decimal, 175.2 degrees. That's going to be the answer. So this is question number 8. Question number 7 has been from the concept called as planes, which is deleted and which is shifted to for the pure mathematics. Therefore, we are not doing that one. Now question number 8. An underground storage tank is being filled with liquid as shown in the diagram. Initially, the tank is empty. At t times hours after filling begins, the volume of the liquid is V meter cube and the depth of the liquid is h. Given that the volume is 4 by 3 h cube, the liquid is poured in a rate of 20 meter cube per hour. So dV by dt, we are adding it 20, so plus 20, but owing to a leakage, the liquid is lost at a rate of h square. So loss means minus kh square. Now we know that the volume is 4 upon 3 h cube. So I'm going to find dv by dh is equal to 4 upon 3 h cube, derivative is 3h square. So what do I get it out from there? dv by dh is equal to 4h square, but I want dv by dt, so dv by dt is equal to 4h square. Move the dh at the other side, dh upon dt. So plug in that one over here. So it becomes 4h square dh upon dt is equal to 20 minus kh square. Bringing all the terms on one side or making dh upon dt as a subject. So 20 minus kh square divided by 4h square. So dh upon dt is equal to 20 divided by 4h square is 5 upon h square minus kh square upon 4h square is k upon 4. But I think so they have given some values for us. The values are h is equal to 1, dh upon dt is equal to 4.95. So 4.95 is equal to 5 upon 1 minus k upon 4. So 4.95 is equal to 5 minus k upon 4. So k upon 4 is equal to 5 minus 4.95. So k is equal to 5 minus 4.95 is 0.05 times 4, which is 0.2. So I got the value of k as nothing but what? 0.2. So plug in that k value as 0.2. So dh upon dt is equal to 5 upon h square minus 0.2 by 4. So which that becomes as 1 upon 20. 1 upon 5 times 4 is 1 upon 20, because 1 upon 0.2 is 1 upon 5. So 1 upon 5 times 4 is 1 upon 20. So this is the first part. Second part, verify 20 h square upon 100 minus h square is equal to this much. So he is asking us to verify this one, and it is just only 1 mark question. So just simplification. So what am I going to do? I am going to copy this one and take it to the next page. I have to verify this part. So what am I going to do? I am going to take this part, minus 20 plus 2000 divided by a plus b times a minus b is a square minus b square. So it becomes negative 20 plus 2000 divided by 100 minus h square. I take the common denominator 100 minus h square, do the cross multiplication, negative 2000, then plus 20 h square, positive 2000. So 2000 gets cancelled, so it becomes 20 h square upon 100 minus h square. That's going to be the answer. 1 mark question. Now to the last part. Hence solve the differential equation of in part 1, obtaining the a in terms of h. So we have to obtain in terms of h. So I have to solve the differential equation. So what is the differential equation? dh upon dt is equal to 5 by h square minus 1 upon 20. So I quickly add a page over here. So the differential equation was dh upon dt is equal to 5 upon h square minus 1 upon 20. So this differential equation has to be solved. So dh upon dt is equal to, if I do this one, it becomes 10 100 minus h square upon 20 h square. So bringing all the line terms on one side, 20 h square upon 100 minus h square dh is equal to dt. Then apply the integral on both sides. Integral. In part 2, this is the partial fractions has been just now been given the partial fractions as negative 20 plus 2000 divided by 10 minus h times 10 plus h dh is equal to dt. Now the integral, so partial fractions have to be done for this one. So before that, because the thing is it is a partial fraction, so let us first complete the partial fractions for this one. 2000 divided by 10 plus h times 10 minus h is equal to a upon 10 plus h plus b upon 10 minus h. So it becomes 2000 is equal to a times 10 minus h plus b times 10 plus h. So I plug in h is equal to 10, so 2000 is equal to a times 0 plus b times 20. So b is equal to 100. Then I take h equal to negative 10. So it becomes 2000 is equal to a times 10 plus 10 plus b times 0. So a is equal to again 100. So I got a as 100, b as 100. So I will be continuing with this one. One more page has to be added. It's a long question. So it becomes integral of negative 20 plus a is 100 upon 10 plus h plus b is also 100 upon 10 minus h. Total dh is equal to dt. Now minus 20 integral is 20h, 100 ln 10 plus h plus 100 ln 10 minus h, but don't forget to divide by minus 1 is equal to t plus c. So I got the integration as any values has been given. So but before that, first let us simplify it out so that make it easy. Minus 20h plus 100 ln 10 plus h minus 100 ln 10 minus h is equal to t plus c. So any other things has been given. Let us go back to the question. It's a long back. It's same thing, h is equal to 1, d is equal to dh upon dt, and one most important thing is initially the tank is empty. What does it mean? At t is equal to 0, h is equal to 0. So what am I going to do? At t equal to 0, h is equal to 0. T is equal to 0, h is equal to 0. So 0 plus 100 ln 10 minus 100 ln 10 is equal to c. So c is equal to 0. So I directly get it out over here. Minus 20h plus 100 ln 10 plus h upon 10 minus h is equal to t. What is being asked? What is the final question being asked? Obtain t in terms of h. So we got it out. T in terms of h. That's going to be the final answer. Minus 20h plus 100 ln 10 plus h by 10 minus h. Question number 9. The constant a is such that integral of this one is equal to c, so that a satisfies this equation. So we have to do integration by parts. So what does that becomes now? Integral of x e to the power of 1 upon 2 x dx is equal to 6 from the limit 0 to a. So we have two functions, the algebraic function and exponential function. So use the acronym RATE, algebra and exponential. A stands for algebra, algebraic. E stands for exponential. We can see that the algebra is coming first and exponential is coming second. So algebra is considered as first function, exponential is considered as the second function. So the formula will be very simple. First function, integral of second function. So first function is x, integral of e power 1 upon 2x is e power 1 upon 2x upon 1 upon 2. Then every time it is minus, minus, integral, derivative of the first function. What is the derivative of the first function? The first function is x, so x is 1 times integral of second function, integral of the second function. What is the integral of the second function? Just now we fought e power 1 by 2x upon 1 upon 2, then whole dx. So only the thing is we have to consider which is the first function and which is the second function. So in that acronym, algebra is the first, exponential is the second. So we consider x as first function, e power 1 upon 2x as the second function. Now the limits, entire limits is 0 to a. We will do that limits. First we are doing without limits. So it becomes 2x e power 1 upon 2x minus 2 integral of e power 1 upon 2x dx. So this one upon further integral 2x e power 1 upon 2x minus 2 e power 1 upon 2x upon 1 upon 2. So now because it is having the limits, we know not write c. So it becomes 0 to a is equal to 6. So Substitute the upper limit 2a e to the power of 1 upon 2a minus 4 e to the power of 1 upon 2a minus 0 minus 4 e to the power of 0 is equal to 6. So it becomes, we have to get the value of a. 2a e to the power of 1 upon 2a minus 4a to the power of 1 upon 2a plus 4 is equal to 6. So 2a e to the power of 1 upon 2a is equal to 6 minus 4 is 2 plus 4 e to the power of 1 upon 2a. So what am I going to do? I am going to divide with 2 on both sides and also e to the power of 1 upon 2a on both sides. So it becomes a is equal to 2 gets cancels, negative e to the power of 1 upon what is this e to the power of negative 1 upon 2a plus 2. So this is going to be the value of a. What has been asked? Verify by calculation that so it is being asked so that a satisfies this one. X is equal to 2 plus e to the power of 1 minus 1 upon 2x. So we can just replace a with x. So x is equal to 2 plus e to the power of minus 1 upon 2x. So x satisfies that equation. Next, verify by calculation that the root lies between 2 and 2.5. So f of x is equal to x minus 2 minus e to the power of minus 1 upon 2x. So I'm going to write it out f of 2 minus 2 minus e to the power of minus 1 upon 2x. It's obviously a negative number. F of 2.5. So it becomes 2.5 minus 2 minus e to the power of minus 1 upon 2 times 2.5. It's going to be the positive number. So as f of 2 and f of 2.5 are having opposite signs, root lies between 2 and 2.5. Next part of the question, what is being asked? Use an iterative formula based on the part 1 to calculate the value of a, correct to 2 decimal places, each iteration in 4 decimal places. So we have to do each iteration in 4 decimal places. So what was the formula that we have to quickly add it on a new page? The formula that we got was x is equal to 2 plus e to the power of negative 1 upon 2x. So we have to frame an iterative formula. Xn plus 1 is equal to 2 plus e to the power of negative 1 upon 2xn. So this is iterative formula. So what am I going to do? I am going to take n is equal to 0. Okay, so it becomes x1 is equal to 2 plus e to the power of negative 1 upon 2 x0. So initial value we can take it out anything value between 2 and 2.5. So we can start with 2. So it becomes 2 plus e to the power of negative 1 upon 2 times 2. Use the calculator and get 4 decimal places. So 2 plus e to the power of negative 1 divided by 2 times 2. So this should be giving me 2.3679, 4 decimal places. Now next time I am going to write out n is equal to 1. So x2 is equal to 2 plus e to the power of negative 1 upon 2 x1. So 2 plus e to the power of negative 1 upon 2 times 2.3679. So I go there, 2.3679. So it becomes 2.3061. Now next I am going to write out n is equal to 2. So it becomes x3 is equal to 2 plus e to the power of negative 1 upon 2 x2, which is 2 plus e to the power of negative 1 upon 2 times 2.3061. So it becomes 2.3061 it becomes 2.31657. Now I'm going to write as n is equal to 3. So x4 is equal to 2 plus e to the power of negative 1 upon 2 x3. So 2 plus e to the power of negative 1 upon 2 times 2.3157. So I take the calculator, 2.3157. So it becomes 2.3142. Still I do one more time. N is equal to 4. So it becomes x5 is equal to 2 plus e to the power of negative 1 upon 2 x4, which is 2, which is equal to 2 plus e to the power of negative 1 upon 2 times 2.3142, which gives me 2.3144. I stop over here. Why do I stop over here? I can see that when I do the two decimal places, it becomes 2.337. This is 2.31, this is 2.32, this is 2.31, this is 2.31. It's repeating. So whenever it is repeating, that's going to be the answer. So answer is 2.31. Last question, the complex number omega is given by this one. Find the modulus and the argument of omega. So modulus of omega is equal to square root of negative 1 upon 2 whole square plus root 3 upon 2 whole square, which is 1 upon 4 plus 3 upon 4, which is 1. Argument of omega, it is tan inverse of root 3 upon 2 upon 1 upon 2, which is tan inverse of root 3, which is tan inverse of root 3 is nothing but what, pi by 3. But now where is this complex number? It's not just pi by 3. You have to be very much careful. So I take the complex number. So Argand diagram, x is negative 1 upon 2 and positive root 3 upon 2. X is negative, y is positive, means it will be somewhere in the second quadrant. So this is negative 1 upon 2 and this is positive root 3 upon 2. So argument means always with respect to x-axis, positive x-axis. So we got it on the theta, which is pi by 3. So it is pi minus pi by 3, which is 2 pi by 3. That's going to be the argument. 2 pi by 3. Check this position of the complex number in the Argand diagram and decide it out where is going to be the complex number, and in that way I got it as in the second quadrant. So second quadrant will be always pi minus the argument what we got, pi minus pi by 3, which is 2 pi by 3. Now coming, the complex number z has a modulus r and the argument theta, and the theta lies between negative pi by 6 and positive pi by 3. State the modulus and argument of omega z and z by omega. So z is a complex number with modulus r and argument is theta, and omega, just now we got modulus is 1 and argument is 2 pi by 3. Now I want modulus for z omega. Modulus of z omega will be nothing but what, modulus of 1 times r, which is nothing but what, r. Then argument of z omega will be argument of z plus argument of omega, which is theta plus 2 pi by 3. Next time what is being asked, z by omega, modulus of z by omega. So z by omega, z is r and omega is 1, so it is going to be the r. And argument of z by omega, in division the argument gets subtraction, so argument of z minus argument of omega, which is theta minus 2 pi by 3. In multiplication the argument gets added, and in the division the argument gets subtracted. That's going to be the answer. Hence explain why in the Argand diagram the point z, z omega and z by omega are the vertices of an equilateral triangle. So they are the vertices of an equilateral triangle. Why is it so? So in an Argand diagram, we try to draw an Argand diagram. Z. Just now we got z as, or omega as 2 pi by 3. What is he asking? What are the three complex numbers? Z, omega z, and z by omega are the vertices of an equilateral triangle. Z is having a theta. So let us take somewhere over here. Theta. It is theta lying between minus 60 and positive 60. So this is positive 60 and lying is negative 60. So the theta can be over here in the first quadrant or in the fourth quadrant. So we will assume that it is in the first quadrant. Okay. So we assume that this angle is theta and this argument is, this modulus is r. Now this is z, a denoted by z. Now let b is denoted by z omega. Z omega also has same length. So whatever the length is there, the same length we take it, but at an angle 2 pi by 3 to what? 2 pi by 3, because we have come to know that it is 2 pi by 3. So added 120 degrees, 2 pi by 3. So this is B Z omega. Now we take another one, C. Its length is also equal to same R, and again add 2 pi by 3. Okay, so let us go again, draw again. So its length is also be same R, and already one 2 pi by 3 is there. From there, theta minus 2 pi by 3. Z omega is theta minus 2 pi by 3. So move it minus 2 pi by 3 over here. Same length. So this is 2 pi by 3. From theta minus 2 pi by 3. And its length is also R. Now we know that angle in a circle is always 360 degrees. So this is already 120, this is already 120, so the remaining has to be nothing but what this angle has to be, 120. So if at all I clear it off and write neatly to make it to understand, and I increase the font size so we can come to know this angle was 120, this angle was 120, so this angle will be 120. So now when we draw it out, we can see that it will form an equilateral triangle, because what it says, all the angles are same. So what we can find it out is, if I draw this one, because when we see that, I make it understand in a clear way. I draw in a different color. Okay, I take a dark blue. You can see that this forms R and 120. So this side and this side and this side will be getting all equal sides if at all we are going to calculate by using the cosine rule. So I'm going to draw the cosine rule over here for AC. You can get it out, r square plus r square minus 2 times r times cos 2 pi by 3. Similarly, AB also is going to be r square square root r square plus r square minus 2 times r times cos 2 pi by 3. Similarly, BC is also going to be square root of r square plus r square minus 2 times r times cos 2 pi by 3. All are equal sides. So if three sides are equal, it's going to be an equilateral triangle. And the last part of the question, in an Argand diagram, the vertices of an equilateral triangle lie on a circle with a center origin. One of the vertices of an equilateral triangle is 4 plus 2i. Find the complex numbers and represented by the other two vertices. Give your answer in the form of x plus iy, where x and y are exact complex numbers. So one of the complex number is z is, let it is 4 plus 2y. What is the argument of z, which is square root of 4 square plus 2 square, which is square root of 20, which is 4 times 5, 2 root 5. And argument of z will be tan inverse of 2 upon 4, which is tan inverse of 2. Okay, so that's going to be the, what it says, the argument. Now I want, just now we have done it out in the part 3 that the complex number z, z omega and z by omega are the three vertices of a what is this equilateral triangle. So if at all I consider z is 4 plus 2y, then z omega will be the next vertex. So in order to get the vertex of a equilateral triangle. So what was omega? Do we know omega? Omega we know it as minus 1 upon 2 plus I root 3 upon 2. So I want to get z omega. Z omega is 4 plus 2y times minus 1 upon 2 plus I times root 3 upon 2 is going to be one of the complex number or one of the vertex of the equilateral triangle. So multiply that one, it becomes z omega becomes minus 1 upon 2 minus this one is minus 2 minus I plus 2 root 3I, and now multiply this one with, it becomes minus 2 root 3I, then 2 gets cancelled plus I root 3. So it becomes I square root 3. So minus 2 minus I plus 2 root 3I minus root 3. So it becomes minus 2 minus root 3, then plus I common 2 root 3 minus 1. So this is one of the complex number. Minus 2 minus root 3, then plus 2 root 3 minus 1 I. So in order to get the another complex number, which is z by omega, is another vertex of the equilateral triangle. So z is nothing but what, 4 plus 2y, and omega is minus 1 upon 2 plus root 3 by 2I. So what am I going to do? I am going to do the rationalization, multiply with minus 1 upon 2 plus minus root 3 upon 2 I root 3 upon 2 divided by minus 1 upon 2 minus I times root 3 upon 2. So it becomes, multiply it out, it becomes minus 2 minus I when I multiply this one with 4 plus 2y. When I multiply with minus I root 3 by 2, it becomes minus 2 root 3I, then minus I square root 3 divided by this one modulus. Just now we know that it becomes minus 1 upon 2 whole square minus root 3 upon 2I whole square. So it becomes 1 because it's modulus. Basically the denominator becomes 1. So it becomes minus 2 minus I minus 2 root 3I plus root 3 divided by 1 upon 4 plus 3 upon 4, which is 1. So it becomes minus 2 plus root 3, then I common minus 2 root 3 minus 1. So these are the two complex numbers. So the first complex number is 4 plus 2i. The second complex number is minus 2 plus root 3, then 2 root 3 minus 1i. And the third complex number is minus of 2 minus root 3 minus 2 root 3 plus 1i. These are the three complex numbers which will form an equilateral triangle. That completes the question and that completes the paper. See you in the next paper. Bye.